So hey everyone, welcome back to another video on my channel. In this video, I'm going to start numbers algorithm in the DSA part. In the previous videos, I have already covered topics like pattern printing and I have solved over 3 to 4 pattern printing problems in those videos. In case you haven't checked it out yet, I will be leaving the link in the description. You can definitely check that out. So without wasting any time, let's start the video. In the numbers algorithm in the DSA part, one of the most important techniques is to extract the digits of a number. So we have given a number that is 7,789. When we extract the digits of a number, we get output like 9877. Basically, we extracted the digits of that number. So how can we achieve that? So to achieve that, we just have to modulus the number with 10 to get the remainder, which is nothing but the last digit of our number. Then we have to divide the number by 10. Then again modulus 10, we get the output 8, which is nothing but the third digit of the number. Then again divided by 10. Then we get 77 as the number. Then we again do modulus 10, we get the output 7, that is nothing but the second digit of the number, and then we again divide by 10. Then we get 7, 7 modulus 10 is equal to 7, which is nothing but the first digit of the number. After that, when we divide by 10, we get 0. So this is the base condition or the stopping condition of the algorithm. When the number becomes 0 after recursively division by 10, at that point, we have to stop the loop or the algorithm. So in terms of coding, the algorithm will look like this. We will use a while loop where while the number is greater than 0, or we can also write while number not equal to 0. We will extract the last digit by modulus 10 with the number. Then after extracting the last digit, we will divide the number by 10 until the number is greater than 0. At the point when number is equal to 0, at that point our algorithm will stop and give the output. The time complexity of the algorithm is log n because in every iteration of the while loop, the number gets divided by 10. So our loop will run for log n times. So that's why the time complexity of the this technique is log n. I hope that's very clear. Some of the applications of these techniques are extracting the digits of a number, like the technique itself it is, and another application is to reverse a number, then to count the digits of a number, Armstrong number, SPY number. All these are applications of this technique. So let's go and solve one of the application of this technique, that is count of digits. In this problem, we will be given an input. As you can see in this sample, we are given the input that is 14635. The output is nothing but the number of digits in that number. So this is our predefined boilerplate code that is given here. So without wasting any time, let's start coding. It has already defined while loop for us. As you can see, in the first line, it takes the input of the number. Then it has already initialized a counter variable. In case you don't know a counter variable, basically to return the number of digits of a number, we have to keep a counter variable where after extracting each digits, we will increment the counter so that we will finally get the number of digits in the number. So let's start the coding. While num is not equal to 0, we have to extract the last digit of the number, that is nothing but num percentile 10. Then we have to divide the number by 10 so that we can get the next digit of the number. Then we have to increment the count. Then the count is already printed over here. Now we just have to click the run button. I think we have to log in here. 1 minute. It's saying to log in the system. I haven't used this platform since a long time. Let me just log in quickly. I think I have a bad internet connection right now. It will take some moment. As you can see, our output is completely correct. According to the sample input, our output is correct. We just have to submit the code. As you can see, the problem is totally correct. But is that the most optimal approach? I think it's not because we are using a while loop, then we are doing three operation inside that while loop. We are getting the time complexity log of n. I think we can do a better job than that. I will explain how. Now let me open the calculator. Let me type some random digits over here and then click log. What do we get? 2.89 for the 789 number. Let me clear. Let me click 9999 log. What we get? 3.99. Let me click another number 78953, then click log. What do we get? 4.89. Can you see a pattern over here that if we do logarithm value for any given number, we get the value that is 1 less than the number of digits in that number. Is it clear? Or I shall repeat again. When we do logarithm for any number 89, when I find out the log of 89, then we get 1.94. Then if I add plus 1 to this value, then we get the number of digits of the number. So our most optimal approach will be int, or we have already a count variable over here. Count is equal to math.log 10. It is already a predefined number in the or predefined method in the math class in Java. Then we have to pass the number over here, then plus 1. Then we have to typecast the whole thing as integer because the math class methods return the value in double value. So we have to typecast with int. Now let's check the output. Isn't it exactly same as our previous output? But the difference is that the time complexity of the code reduces significantly because we are getting the output in just one operation. So that's why the time complexity of our code becomes big O of 1, which is constant time complexity. So we don't have to write any loops or any operations inside that. One single operation does our job for us. So this is the most optimal approach for this particular problem. So this is it for this video. Thank you for watching. We will meet again in the next video.